We are about to look at an application of the Pythagorean Theorem. Quick review of the Pythagorean Theorem. You have a right triangle setting. The two sides that make up the right angle are going to be called A and B, and the longer side opposite the right angle is going to be called C here, the hypotenuse. The Pythagorean Theorem states that the length of C squared equals the length of A squared plus B squared. Taking the square root of both sides of this equation, we get C equals the square root of A squared plus B squared. We're going to ignore the plus or minus here because of the application. We're only interested in the positive result. If we look at the question that we're dealing with, we have a billiard table and we're going to shoot the ball and it's going to travel on a diagonal. So to create our right triangles, we're going to drop a line that is perpendicular to the base from the opposite vertice, and now we have a distance in this lower right triangle of 2.5, and of course the height is 8. So in this right triangle we can calculate the distance of the hypotenuse, and we're going to do that using the spreadsheet. So let me clear all the pictures, get our keyboard up, and in this first cell I'm going to put in 2.5. In the second cell I'm going to put the other side of the right triangle, 8. In here I'm going to put the formula for calculating the length of the hypotenuse, so I start with an equal sign. I'm going to my other keyboard because I'm going to type in SQRT, and then when I put in the parentheses it recognizes that as a built-in function and capitalizes it. I'm going to now take the first distance, 2.5, by tapping on it, caret 2 to square it, plus tap on the second side, caret 2 to square it, and then close my parentheses to get the formula, and the green check mark gives me the answer for the hypotenuse, 8.3. Going into the other cell, because it's an up and back, so I'm going to double that. I start with an equal sign and I take 2 and multiply it times the cell where the 8.38 is in, and green check mark gives me the answer of 16.763. So there's an application of the Pythagorean theorem.